So hello everyone, welcome to another new session of AB's chemistry classes. This is the third session on atomic structure, and in this session we will discuss the most important topic of this chapter, that is the Bohr's atomic model. So let's start today's session. In the previous session we have studied the earlier atomic models, that are Thomson's plum pudding model and Rutherford's atomic model, and both the models were unable to explain the actual atomic spectra, and Rutherford's model was unable to explain the stability of an atom. To rectify these problems, Niels Bohr introduced his atomic model. In his atomic model, Niels Bohr kept the primary idea of Rutherford intact. He also considered that an atom consists a nucleus that contains all the positive charge and mass of an atom, and electrons are revolving around this nucleus following some circular orbit, and while rotating, if the charge of an electron is E, mass of an electron is m, the velocity of electron is v, and the total charge of nucleus is Z E, and radius of an orbit is r, then the Coulombic attraction force between the nucleus and the electron will be exactly equal to the centrifugal force of the electron while rotation. That is, Z E square divided by r square will be equal to mv square by r, which was also the concept of Rutherford's atomic model. With this condition of Rutherford, Niels Bohr also introduced some new conditions for an electron to rotate in an orbit. In Rutherford's atomic model, Rutherford told that electrons can rotate around the nucleus following any circular orbit, but Niels Bohr told that electrons cannot rotate in any circular orbit. There must be some conditions for an electron to rotate in an orbit. The electrons can rotate only those orbits for which, while rotating, the angular momentum will be some integral multiple of h by 2 pi. So, number 1, while rotating in an orbit, angular momentum of an electron will be some integral multiple of h by 2 pi. What is that? The angular momentum is represented as mvr, where m is the mass of the electron, v is the velocity of an electron, and r is the radius of an orbit. It will be equal to n into h divided by 2 pi, where n is any whole number, that is 1, 2, 3 to infinity. For first orbit, n is equal to 1, for second orbit it is equal to 2, and so on. So this was the first condition of an orbit. So we are writing this here. mvr will be equal to n into h divided by 2 pi. The second condition of Bohr's orbit was, while rotating in an orbit, in a Bohr orbit, electrons will neither absorb nor emit any kind of energy. So the energy of an electron will be constant while rotating in an orbit. So these orbits were also termed as static orbits. Static orbits doesn't mean that electrons will be in static condition in those orbits, but the electrons will rotate, but their energy will be static, that is, their energy will be constant in that orbit. So second condition was, while rotating in an orbit, electrons will neither absorb nor emit any energy. These orbits are called static orbits. The third condition was, in presence of some external energy source, the electrons can absorb some energy from that source and can jump to some higher orbits. That is, if there are second and third orbits, then from an external energy source, electrons can absorb some energy and can jump to some higher orbits. Electrons will not remain in that higher orbit for lifetime. They will return to the ground state and will emit some amount of energy. So the third condition was, in presence of some external energy source, electrons can absorb some energy to jump to some higher energy level and from higher energy level it can emit some energy to return to the ground energy level. So these were the conditions of Bohr's atomic model. Now based on this model, one can calculate the radius of an orbit, the velocity of an electron while rotating in an orbit, energy of an electron while rotating in an orbit, and the amount of energy which will be absorbed or emitted when an electron jumps from some lower energy level to higher energy level or some higher energy level to lower energy levels respectively. So now let's try to calculate the radius of an orbit following this model. So radius. Earlier we have seen that in any Bohr orbit, the Coulombic attraction force will be equal to the centrifugal force of an electron. So Z square divided by R square will be mv square divided by R. So V square will be equal to Z square divided by mr. We are writing this equation as equation 3. And from the condition of Bohr's orbit, we have found that mvr will be equal to n into h divided by 2 pi, or v will be equal to nh divided by 2 pi mr, or v square will be equal to n square h square divided by 4 pi square m square r square. This will be equation 4. Now from equation 3 and 4 we can say that z square divided by mr will be equal to n square h square divided by 4 pi square m square r square, or r will be equal to n square h square divided by 4 pi square m z square. So this is the equation to calculate the radius of any Bohr orbit. So we are writing this here. R will be equal to n square h square divided by 4 pi square m z square. I hope it's clear for you. Now let's try to calculate the velocity of an electron while rotating in an orbit. Velocity. So from the condition of Bohr's orbit, we have seen that mvr will be equal to n into h by 2 pi. So v will be equal to nh divided by 2 pi mr. Now putting the value of r in this equation will be v is equal to nh by 2 pi m into 4 pi square m z e square divided by n square h square. So v will be equal to 2 pi z e square divided by nh. So this is the equation to calculate the velocity of an electron while rotating in a Bohr orbit. Now let's try to calculate the energy of an electron while rotating in a Bohr orbit. So in Bohr's atomic model, there is a nucleus at the center of an atom, and electrons are rotating following some circular orbit around this nucleus, and we also considered that the radius of an orbit is r. The charge of an electron is E, the mass of an electron is m, the velocity of the electron is v, and total charge of the nucleus is z into E. Right? We have done all these things earlier. Now the total energy of an electron will be summation of its kinetic energy and potential energy. So kinetic energy can be written as half mv square plus potential energy equal to, for an electron while rotating in an orbit, we have seen that mv square by r will be equal to z e square divided by r square. So v square will be equal to z e square divided by mr. So putting this value of v square in this equation, we will get half into m into z e square divided by mr plus potential energy. So it will be z e square divided by 2r plus potential energy. Now the potential energy of an electron will be equal to the work done required to bring an electron from infinite distance to some distance r. Okay, so to bring some electron from infinite distance to an orbit, the amount of work that will be required will be equal to the potential energy of an electron. Now we have seen that, we know that work is equal to force into distance. Here the force is equal to Coulombic attraction force between the nucleus and electron, so it will be equal to z e square divided by r square, and we are dividing this whole distance into some small distances, and each small part is known is termed as dr. So work done will be equal to z e square by r square into dr. That will be work done for this small distance, right? Now for whole distance, the work W will be equal to integration r equal to infinity to r is equal to r to z e square divided by r square into dr. So solving this integration, we get z e square minus z e square divided by r, right? So this is the potential energy. So this is the potential energy. So putting this value of potential energy, where we get z e square divided by 2r minus z e square divided by r is equal to Z minus Z square by 2R, this is the total energy. Now putting this value of R, we have already seen that R is equal to N square H square divided by 4 pi square M Z E square. Putting this value of R in this equation, we get energy equal to minus Z E square by 2 into 4 pi square M Z E square divided by N square H square is equal to minus 2 pi square M Z square e to the power 4 divided by N square H square. So this is the equation for total energy of an electron while rotating in nth Bohr orbit. So we are writing this equation here. Energy of an electron will be equal to 2 minus 2 pi square M Z square e to the power 4 divided by N square H square. Now we will calculate the amount of energy a electron will absorb when it will jump from an energy level N1 to energy level N2, where N1 is greater than N2. So the amount of energy will be absorbed will be the energy difference between these two levels. So we can write that the amount of energy will be absorbed will be equal to E of N2 level minus energy of N1 level. And from Planck's equation, we have seen that this energy level will be equal to H into nu, right? So it will be equal to minus 2 pi square M Z square e to the power 4 divided by N2 square H square plus 2 pi square M Z square e to the power 4 divided by N1 square H square. So the common terms here are 2 pi square M Z square e to the power 4 by H square. These are the common terms. So we will get 2 pi square M Z square e to the power 4 divided by H square will be equal into 1 by N1 square minus 1 by N2 square, or nu will be equal to 2 pi square M Z square e to the power 4 divided by H cube into 1 by N1 square minus 1 by N2 square, or nu is equal to C by lambda. We have seen this in earlier sessions. Will be equal to 2 pi square M Z square e to the power 4 divided by H cube into 1 by N1 square minus 1 by N2 square, or 1 by lambda will be equal to 2 pi square M Z square e to the power 4 divided by C H cube into 1 by N1 square minus 1 by N2 square. 1 by lambda is called Webb number, that is nu bar. Now for hydrogen atom, the atomic number, that is Z, will be equal to 1. So for hydrogen atom, nu bar H will be equal to 2 pi square M e to the power 4 divided by C H cube into 1 by N1 square minus 1 by N2 square. In this term, all the terms are constant: pi, mass of an electron, charge of an electron, velocity of light, H is Planck's constant. This is termed as Rydberg's constant, RH into 1 by N1 square minus 1 by N2 square. The value of Rydberg's constant is 109677 centimeter inverse. In the next session, we will do some numerical problems on these equations. So that's all for today's session. See you in the next session. Till then, stay home, stay safe, and always put your mask on while going outside in an emergency. Thank you.